All right, so there was a report yesterday by SentinelOne that we're gonna go through a little bit here. That talked about a recent Swift application, GUI application that downloads PDF, downloads another file to execute, and great opportunity to talk about some Swift and some ARM stuff. So let's dive straight into this. We're inside of Binary Ninja, and I have that lesson one Mach-O here. And just to go back and look at the blog post, we're going to focus on the first stage of this. So if we scroll down, first stage, this dropper places PDF. So we have this lesson one. We're looking at the ARM 64 slice. And what we want to look at is, well, what I'm going to focus on is how this happens. So this connection to this domain to grab this other file that then it downloads and executes. Okay, so this is a GUI app. So if you start at start, all it's going to do is execute this NS application main function, right? So it's hard to kind of know where to go from here. So just to share something I do sometimes with Swift apps, especially, some functions are passed a lot of parameters because if you're passing strings in Swift, strings are structs, and that's going to be passed in 2 registers per string due to the size of these structs. And I tend to look for functions that have the most parameters and see if there's anything interesting with that. So luckily with Binary Ninja, that's like super easy to do. So just to show an example, something I wrote earlier today, just a simple function to sort functions by parameter, like size or count, and then just print out that function and the parameters, and then just go through there and like kind of just use that as a target. So if we run this, that's going to execute, and then that's going to be here. And let's just kind of scroll this up. And then from here, we can kind of work backwards. So we can look at the functions that have the most parameters, like these are showing like 0, for example. As we go up, the count will increase. We got 1 for all of these. And this is just a shortcut that I sometimes use. All right, so these two are potentially interesting. I looked a little bit at this before, so to kind of give it away, we're going to look at both of these really quickly to just see what they may do, and that may help us figure out where to focus our attention. All right, so we have these two functions. Let's look at the first one. This one has 8 parameters that are passed to it, which is pretty crazy. So if we look at this, we can see all these parameters being passed. And just kind of look at this really quickly. We see URL is being initialized. We see a data write for something. We see NS file manager for file operations, POSIX permissions. All right, so a couple things here that may tell us what may be happening, some file operations, and there's a static object here, which we talked about before in another video. All right, so let's see what calls this. Oh, we have this NS task. So this may be how the function or the secondary file is being executed. So an NS task, and then we're setting this executable URL to be something that's bridged from a Swift URL type and setting arguments. Okay, cool. So this ends up using potentially the download to then use an NS task and execute this other file. So that's the first one. Now let's look at, oh, first let's look at what calls this, because that might be interesting. So if we do that, we click on this and we look at its cross references, we'll see that this calls it, this returns this function that has all these different arguments here, and it looks like a lot of this is based on this potential array that then each argument is then like offsets of this array, it looks like. And then let's see, this is what actually returns it. So let's see what this is from. And it looks like this is part of a block, right? So we can see this is set up around this block, this stack block, and this block copy. And usually from other samples that are similar to this, this block is then passed to, to this data task with request completion handler. So as a handler to handle this URL session, what happens after that is successful, it will then execute this block. And it looks like this block then does an NS task, and this is probably related to the download. Okay, so this first one, we have an idea of what this does and we can dive in deeper. This is just to kind of familiarize yourself with like where do you go, where do you start, and this is really helpful for that, figuring out parameter count and then going from there. Okay, so let's look at the next one. This one, I put this here as a tag because I wanted to spend time on this one. I just haven't had a lot of time yet to kind of dig into this, so let's just talk about it. So this has 8 arguments as well that are passed to it, and it looks like this is related to some URL requests. We have a URL session, and this is actually, oh, interesting. So this is the function that we were just looking at before that then uses that block. Cool. So this also has passed 8 arguments. So let's look at that really quickly. What is the cross-reference to this? We can see that here. And this, I saw this earlier, this leads us to nowhere, which is not very helpful. And if we look at the disassembly, we're not where we need to be. We know that 8 arguments are going to be passed to this function. They're going to be passed via registers. So we should see like a stack of different register instructions to move to these, x0, x1, x2. Don't see that here. So we need to go back, focus. So that is 400 and then C. So let's look at that and let's find it. 400C. Here we go. Put this tag here to try to help. So looking at the cross references in the decompilation, it didn't really bring us there. So you kind of have to go to the disassembly and see what's actually happening here. But the good thing about this is we can start piecing together what is passed to this function, which then creates that URL session, which then uses that block when it executes that URL session to some domain, grabs a file, and then uses an NS task to execute that file. The cool thing about this is we can talk about some Swift stuff, right? So this is always interesting, and it's always something that I find can be confusing with Swift. Luckily, I've been shown this before, and it is really helpful. So we see here all the way at the top, we see this move X8 and then move K, right? So this is using a left shift. So it's putting this value of D all the way at the end of this, right? So you can see what this looks like here. And this is going to be a size of a string. Okay, so that is then going to be moved into X0. So now we have our size, and Swift strings are structs that have 2 members here. We have the size, and then we have like a pointer to this in the binary. And you know that this is a large Swift string because it starts with this 8 here, and that's going to be moved into X1. Right? So usually this is how it goes. We have an ADRP to get this, right? So a pointer to this address, and then we're adding an offset to that page. And then there's a subtraction that happens here. And then there's an OR to put this 8 all the way at the end of this. And this is going to be how we know this is a large Swift string. So if we want to find out what this is, we actually can calculate this because we have to add something that's called a native bias, which is 32 bytes. So let's do that math here. So we can do a bv.read, and then we're going to pass in this address. We're going to add 0x20, which is 32 bytes for the native bias. And bv.read allows us to read bytes from a specific address for a specific length. And we know the length of this string because it's here. So 0x1e. We do that. This is going to be the domain, or the location that is going to be used when it actually reaches out and grabs that secondary file, it looks like. And this does match what was in the report here. Cool. All right. So we know that the first register here that's going to get passed to this function down here is an x0, and that's the size. And then this string is going to be made up by x0 and x1. So the next thing we know is going to be that this is that string that's passed into this function. So we're going to keep that in mind. So x1 has that, x0 and x1 is Swift string for URL. Cool. Okay, so now we're going to see what else is passed here. And we have this x2, we have some bytes, this value being moved here, and then we're left shifting, and then left shifting, and then left shifting, right? And then that's these two put together is going to be another Swift string, but this is going to be a small Swift string. And how do you know that? We have to change this. So display as unsigned hexadecimal. Small Swift strings start with this 0xe. And then the size of the small Swift string is the next value after that. So that's an A. So that's 10 bytes long. And we can see this curl AG with curl with a 1, which I think has been seen before by DPRK. And I think that might be mentioned. I think I remember seeing that. Yeah. Okay. Cool. So we see that also being used here, this curl1 agent, right? So we can actually change this to be ASCII characters, and we'll have that NT at the end of this. So curl agent, that's going to be an x2 and x3. So x2, x3 is equal to a small Swift string curl with the 1 agent. Let me just put this like this so I can see it better. Okay, so next thing that's passed in, we can see this here. This already shows up as the characters PW, and we know that that is the actual string because the register next to it, right, this x5 is going to have 0xe, which is for a small Swift string, and after that E is going to be the size of the string, and that is PW. So this is x4, x5 is equal to small Swift string PW, which PW has been seen before for DPRK. Okay, and then we know we start at x0, so there's 8 arguments that are passed to this function, and x0 was the size of that large Swift string for the URL, and then now we're all the way down to x6 and x7, and if we look at this, we would have to go in reverse to see, what this value is and what this value is. So x23 is somewhere up here. It's loaded in from this object, and it looks like this might be used for this string.append for a string that then is appended growth. We're not going to worry about that right now because that's going to be a lot of stuff to cover. We just want to focus on how that URL is used really quickly. So x21, if we look up, we go in reverse, we'll see that that is this object that's passed in. So this is another Swift string that these two registers were then given it looks like potentially the size, and then the growth, the result of the append function to whatever the original string was, and then that's going to be passed in to this function too. Okay, so we know x0, x1, Swift string, another small Swift string, another small Swift string, and another string, another Swift string. So that's why it made up all of these registers, because again, Swift strings are structs and they're passed in. Each Swift string is passed in via two registers to functions, and that's why it's really useful when you're looking at Swift binaries to look at the count of parameters, and maybe you'll find like Swift strings that are then being passed to functions like this. Okay, so if we go in here, we now know arg1 and arg2 are going to be related to the actual URL, right? So we're just going to kind of wrap it up with that because we'll be here a long time if we go through all this, but just wanted to show how that URL is used. And if we go here, we know that arg1 is an x0 and arg2 is an x1. We'll see those two are moved here, right? So this is going to be Swift string, the pointer to bytes, and then x0 was the size, Swift string size. So x22, let's see when's the next time that is used. x22, highlight that, scroll down. We'll see that first it's stored on the stack here. Right, so this is arg0, arg1, just put arg for now. And then that is moved into x1 here, which is then passed into this URL init. And it's passed in as a string, and strings are going to be two registers, so we can expect x0 is going to be passed in here as well, so x0 and x1. And if we look at that, we'll see x28 is used here, and if we go on reverse, go up, x28 is that other part of the Swift string. So that is then used to initialize a URL by passing in a string. And then that will then be used later. So the URL for malicious domain is initialized. And that's not how that's spelled, but that's okay. Okay. Going away from the disassembly for a second, we can then start piecing this together a little bit more. The good thing is this actually shows what we just talked about. URL init is passed in this Swift string, which is two registers wide. And we have arg1 and arg2, which are that URL, the Swift string for the URL. And then we have a URL request initialize. We have this HTTP setter, or this HTTP method setter, which is for a post. We can see that we can just display that differently. This is also a small Swift string, and we can display as actual characters here. And this is user agent. This is also going to be user agent. And then this, another value is being set for this content. And just to kind of wrap this up, we can use R here, content type, and then this is going to be another Swift string. All right, and then that's it for this video. We'll just wrap it up here. We'll see how this is used. We know the URL is used in for this session, and then once that's done, it executes that block, which then does an NS task for that file. All right, thank you.